We are going to look at the question paper, November 2021. We are looking at November 2021. So question 4. Question 4, November 2021. It's analytical geometry question. Right, in the diagram, the circle centered at N with the coordinates -1 and 3, so we can see it there, passes through A with the coordinates -1 and -1, and C with the coordinates -4 and 2. So we can see the A and the C there. Now C, D, and E are joined to form a parallelogram. Now remember, this is now a parallelogram, CDE, BCDE. It's a parallelogram, so we need to notice the properties of a parallelogram. Now, CD is a tangent to the circle at C, and CD is 6 units. Right, now this is a parallelogram whereby they also tell us that BE is parallel to the x-axis. Now before we talk about the tangent, let's talk about this BE being parallel to the x-axis. Now what does that mean? Now if BE is parallel to the x-axis, so this is saying to us that it has the same y value there. So if you look at the coordinates of B, it's -4 and 2. So it means here the y value is 2, because they're saying it's parallel to the y-axis. So it's parallel to the x-axis. So it has the same y value. The y value is the same here. And remember, the same thing applies because CD is also parallel to BE, because this is a parallelogram. So it means the y value at C is the same throughout. Whatever y value there is the y value here, it's even the y value at D. So it also has the same y value there. Whatever we are going to get here will be the same. So we should remember that about this thing of parallel. Right, now CD is a tangent to the circle at C. CD is a tangent. The other thing that we should remember about tangent is that a tangent is perpendicular to the radius. That theorem that indicates that a tangent and a radius are perpendicular to each other. So we should remember that one, about that fact. Right, now that we have explained everything, we can now go to the questions. Remember that CD is 6 units. They have given us that. Right, question number 1. Write down the length of the radius of the circle. Normally when they say write down, you just have to write it down. So, but then let's explain how we get the radius. Now remember, these coordinates here are -1 and 3. And at A is -1 and -1. So it means actually this is the same line there. So if it is the same, it's easy to get the distance, because we just take the y values there and the top y value and subtract the bottom y value. In other words, the length of NA, let's write it down, NA, which is our radius, equals to the y value at N minus the y value at A. So the top y value subtract the bottom y value. So NA is what we want, is our radius. So we can even write it as radius. And then the y value at N is a 3 minus the y value at A, it's a -1. So let's write it as -1. So meaning our radius will be 3 minus -1, which is +1. So it's 3 plus 1, which is 4. So it means the length of our radius is 4. Now let's go to the question number 4.2. The coordinates of C. Now we want the coordinates of C there. Right. So the coordinates of C, as I have explained already, you can see this line is perpendicular to that, so it means we have the same c value there, I mean x value there. So x value is the same here, it's -1, -1, -1, so we can just see it's -1. So the x value is -1. Now the y value, so we are now going to talk about the y value there, because we want the coordinates of c. So to get the y value, we are going to look at what we got there as the radius. Now remember, the radius is 4, meaning from N to C is 4 units. So already we know this distance, so we can do the same thing as we did in number 1, as we did in 4.1 here. So for 4.2, we do the same. We use the same formula, that the distance of NC equals to the y value at C, the top y value there, minus the y value at N. Y value at N. So we do exactly the same thing. So we just repeat them. So NC, we know it's 4. We know that the length is 4, is the radius. Then the y value at C is what we are looking for. So it's the y value, and then minus the y value at N. Already we know that the y value at N is a 3. So we can now simply take the 3 to the other side. So we will have y being 4 plus 3, so which is 7. So it means therefore the coordinates of C are -1 and 7. Right? This was 4.2.1. Now 4.2.2. Now we want the coordinates of D. The coordinates of D. Right. So the coordinates of D. So already I've indicated that the y value at C is the same. So here the same value is the y value. The y value at C is the y value at D. And right, already we said that the y value at C, we said it's a 7. So it is the same y value. So even at D, we will still say the y value is 7, because it's the same y value. And now we're going to calculate the x value. Now remember, they have told us that the distance CD is 6. So we know the distance from C to D. So we are going to use the same properties as we used here of the distance of NC, but now on the y value. So now we are using it on the x values, because the distance from C to D is the y value, the x value at D, subtract the x value at C. So let's do it that way and say CD, it's x value at the right one, the one at the right, which is at D, x value at D, subtract x value at C. So now that is the distance of CD, but already we know the distance, which is 6. Now x value at D is what we are looking for. So that's the value of x that we are looking for. And then we subtract the x value at C. Now, what is the x value of C? Already we have calculated it here. We said it's -1. So we are going to subtract a -1. Right. So it means this is x plus 1. So the plus 1, when it comes this side, it will be a -1. So it means that the x will be 6 minus 1, which is 5. So it means the coordinates there of D, so the coordinates of D are 5 and 7. The area of triangle BCD. Now let's look at this triangle properly. So it's the triangle BCD. So we want the area of this triangle. Right. So it means its height. We can construct the height. So this is the height of the triangle. So this is the height. Now if we check the height, there is whatever value there, this minus this, the value here minus the value here. So we know already that the y value here at C, we said it's 7, and here the y value, it's 2. So 7 minus 2 is 5. So giving us the the height of this triangle to be 5. So the height of the triangle is 5. So now that we want the area, we will say the area is half base times height. Is half base times height. So already we have calculated the height. We said it is 5. Now the base, we are given the base of this is CD, so the base is 6. So it means the area is half times 5 times 6, which is 15 square units. So it's 15 square units. So that is the area of this triangle. Okay, number 4.3. Let us look at 4.3. They say here the circle centered at N is reflected about the line y equals to x. The circle is reflected about the line y equals to x. Remember, reflection about y equals to x. Xy tends to yx, y and x. So we just swap. So that's the reflection about the line y equals to x. Remember, it is the same as calculating the inverse. So when we calculate the inverse also, it is a reflection about the line y equals to x. So x becomes y, y becomes x. Right. Now, M is the center of the new circle. Right. So it means the center of, remember the center of the old circle was N, which is negative 1 and 3. So it was negative 1 and 3. So it means the new center, this was N. So it means M will be, we swap this, it will be 3 and 1. And not 1, negative 1. Excuse me. Right. So it will be, M will be 3 and negative 1. Now, they continue that the two circles intersect at A and F. Right, so it means after the reflection, they intersect at these 2 points. Okay, let's go straight to the question. Number 1, 4.3.1. 4.3.1. Calculate the length of NM. The length of NM, already we know N, so we just use the distance formula. NM will be the square root of x value at N minus x value at M all squared plus y value at N minus y value at M all squared. That is the distance formula. So we substitute, this is x value at N, it's negative 1, minus at M is a 3 all squared, plus at N, y value at N is a 3, minus y value at M is a negative 1. So we can say negative and negative, it's plus 1 all squared. So minus 3 minus 1 all squared is 4 squared, which is 16. 3 plus 1 is also 16. So 16 plus 16 is 32. So our answer is 32. You can even rewrite it as root So this is the same as actually 4, 2. Right, that is the length of NM. 4.3.2. We now want to calculate the midpoint of AF. Now, remember, they said this circle is reflected about the line y equals to x. So that is why this circle will be thrown like this. Then the center, we said, is 3 and -1. So they are touching at A and at F. They are touching at A and at F. Right, if you look at this, the coordinates of A here is -1 and 1 and -1. So if you look at this, it's the same there. So it means the coordinates of F, already we know the y value. The y value is 3. So it is like this is perpendicular to this actually. So the y value is 3. So giving us the coordinates of F, because if we know the y value, it means we also know the x value, because the line here is the line y equals to x. So it means the x and y are equal. So it means the coordinates of F are simply 3 and 3. So now the question is, calculate the midpoint of AF. So now we just want the midpoint of AF. We have the coordinates, so it means the midpoint of AF. The midpoint of AF will be x1 plus x2 over 2, and then simply y1 plus y2 over 2. So that is the midpoint formula. So the midpoint of AF will therefore be x number 1. Anyone is number 1, so we can just say it's -1 plus 3 over 2. And the same thing applies to the y values. It's also -1 plus 3 over 2. So it means the midpoint of AF will be -1 plus 3 is 2 over 2 is 2. Sorry, rather 2 over 2, it's 1. So the midpoint of AF is 1 and 1. Thank you very much. Please don't forget to like, share, and subscribe. Thank you very much.